Hello everyone, hope everyone is doing great. Welcome back to my channel Build with Swinder. As part of this video series, today we will be building the logic for this Leetcode problem 226, which is invert binary tree. In this you are given a binary tree and you just have to invert it. What does this invert means? Basically the roots, let's say if you are standing at this node, the left child of this node will become the right child in the inverted tree and the right child in the original tree becomes the left child in the inverted tree, and this happens for all across all the nodes. So if you see 7, 7's left child is 6, but in the inverted trees 7's right child is 6. Similarly, in the original tree 7's right child is 9, but in the inverted trees 7's left child is 9. So you have to do it across all the nodes. If you remember in my previous videos, there are two ways to solve tree-based problems, either using BFS or using DFS. I'll be showing the DFS way because this one is more intuitive. And to solve it using DFS, you have to know recursion. And if you know recursion, then it's very easy to solve these kind of problems. Uh, I'll show you how to use recursion in this problem. So let's say you have to see that, let's say you are standing at this particular node, right? So this is your root node. What will happen? How to invert? Okay. Initially, you might have some thoughts in your mind how recursion gonna work, but you don't have to go too deep inside the recursion. You just have to have faith in recursion, and you have to come up with a good base cases. Then it's gonna work. So let's say if you are standing at this particular node here, this node. How will you invert the binary tree while you are standing at this node? You have to make this decision greedily. So, assuming that you already inverted the left tree and the right subtree, now for this particular node, whatever is the left child, it should become the right child, and whatever is the right child, it should become the left child. Okay. So let's say you are standing at this node P. So you will assume that you already inverted your P's left child, which is this subtree, and then you will say that I'll invert p dot right, okay, which is this node here. So you already have inverted p dot left, the subtree, this one, and you already inverted this subtree. If you have and you have the nodes, let's say the nodes references you have is I'll just name it L. Then from the right inverted I have R. Now what you have to do is, see, you are standing here and you know that this is inverted, and you have L and R. All you have to do is your P dot right, it becomes L, and your P dot left, it becomes R. As simple as that. Again, I'm going to repeat it. So you inverted the left subtree of your node, you inverted the right subtree of your node. You have some reference L coming from your left subtree. You have a reference R coming from the right subtree. What you have to do now is you just have to swap L and R. So basically P's left will become R, P's right will become L. That's it. You don't have to go too deep inside the recursion. Without even thinking of this, it will be very easy. Otherwise, you will just get stuck. So let's say you have the same function invert tree. I'll just write the same function taking the function definition from the Leetcode, and you just have to invert the tree, and in the parameters you are given the root node. Okay, so if you remember, I have to write the base case here. We will write the base case later, but let's develop the logic for the core logic first. So here you can assume that you already have the reference after inverting your left subtree. So I'll just call the same function invert tree, and I ask invert tree, please invert the left subtree of my root node. and give me the reference. Similarly, I'll say invert tree, please invert the tree on my right subtree of my current node and give me the reference. Once I have the reference, all I need to do is the root left will become R and the root right will become L. And in the end, I have to return this root. Okay. Now, this is our core logic. Now we just have to come up with a base case. If you notice this function here, what could go wrong? Let's say what happens if the root is null. In that case, it will give us the null pointer exception. So it means in the base case, we need to handle the case where the root is null. So if the root is null, what should be the inverted tree of a null tree? It should be null, right? If the tree is empty, the inverted tree will always be empty, right? So this is it. See how easy it is. First, you need to develop the core logic. In this, you just have to think what's gonna happen if you're standing at a particular node. You just have to make decisions greedily, and then you just have to come up with a base case. That's it. What should be the time complexity of this problem? If you notice, I'll be uh, calculating doing this invert tree for each node. So the time complexity would be O of n, where n is the total number of nodes, and the space complexity would be O of h, where h is the height of the tree in the recursion stack. We could argue that this, in the worst case, it could be O of n when the tree is skewed, but for the interview purposes, we could just say that it is O of h, where h is the height of the stack trace or the depth of the stack trace. Now I'll show you the same problem on Leetcode website and we can see how to solve it there. So first I need to write the base case. The base case would be if root is null, then we just have to return the null. And now we have to say that please invert the left subtree of my root node. Then I'll say please invert the right subtree of my root node. And then whatever, what should come to the left part of my root? The right one, right? So the right becomes L. So in the end, I just return the root. So here I'm calling the recursion to invert the left subtrees and the right subtrees. Once those trees are inverted, all I'm doing is I'm putting the reference of right subtree in my left and putting the reference of my left subtree in the right part of my root. So I'll just try to submit this code. Yeah, so it's accepted. I'll just submit it. If you see, you don't have to think too deep initially in the recursion. You just have to build the core logic greedily and then think of the base case. See, this is submitted. So it beats 100% because this is O of n solution. I hope you guys understood the problem and the solution. And if you do, please like this video and subscribe to my YouTube channel. I'll be posting more such videos. See you guys in the next video. Thank you.